So what is basically happening? There are different layers inside the liquid. So each layer, it is basically trying to pull away the other layer so that their speed is decreased. So when we talk about viscosity, it is basically the property which measures the resistance to flow. It measures the resistance to flow which is offered by a fluid layer when another यहाँ पे एक layer, another adjacent parallel fluid layer tends to flow past the other layer. So class, अगर मैं if I'm talking only about this layer, so it means that the other layers, this layer or this layer, they're trying to pull इस velocity को कम करने की कोशिश कर रहे हैं, ठीक है? So it is measured in terms of the steady push force which is operative on the fluid, okay, and which is, and now we want to maintain that same velocity or same, we want that the layer should move with the same force. So it is trying to it's basically a force which is operative on the fluid, which is trying to maintain the same velocity. So we can say that if the force is if F is the force which is required for maintaining the selected velocity difference between the two layers, F will be proportional to A, the du by dx, a small change in the velocity which is there, and a small change the difference between the two layers. Class यहाँ तक clear है? Obviously at constant temperature. Clear है class यहाँ तक? नहीं, दोबारा से repeat करूँ? Clear है. अच्छा, आवाज आ रही है ना? I think मैंने क्लास 11 में पढ़ा भी हुआ है. So your F will be equal to when you remove the proportionality sign, it is equal to eta A du by dx at constant temperature, or you can say that your eta is equal to F A du by dx at constant temperature. Now where eta is called as the coefficient of viscosity of the fluid at given temperature. Now can you define the coefficient of viscosity at a given temperature? Anybody? To define कर सकते coefficient of viscosity is with this, we're using this equation. अब आपको मतलब कि your layers are moving inside the tube. There is laminar flow of the liquid inside this tube class. ठीक है? So now what is happening कि एक layer जो है higher velocity से move कर रही है. Suppose this is moving with u plus du and this is moving with u class. ठीक है? The difference between these layer is dx actually. So now there is a push being offered by the other layers. Now you want to maintain that same difference of velocity of this. You want to move with the same velocity. So you have to apply the force. Okay, so this force is given by A du by dx. Now from this is a proportionality constant. So this is a coefficient of viscosity. Now I want to define the coefficient of viscosity with equation number 1. So how will I do that? In terms of one or unit area की टाइम में भी आप define कर सकते हैं.
Ma'am, the external force required to maintain the velocity difference of 1 unit between two layers which are 1 unit apart, and the area of contact between them is 1 unit. Okay, 1 unit.
Okay, good. So according to this equation, the coefficient of viscosity of a fluid at any given temperature may be defined as, यहाँ से देख लेंगे, may be defined as a force per unit area per unit. This is du by dx. We all know this is velocity gradient. Du by dx is known as velocity gradient. इसकी डिटेल्स की जरूरत नहीं है, आपको पता ही होगा, ठीक है क्लास. So it is defined as the force per unit area per unit velocity ग्रेडियंट। अच्छा फटाफट से इसके यूनिट्स बता दो मुझे।
kg per meter per second.
So इसके यूनिट्स हो जाएंगे, I think we can talk about the force in terms of the dynes, that will be better, because आपका ये F हो गया, F A du by dx। अब बताओ अपने आप सोच के क्या होंगे।
मैम आपका वॉइस लैग कर रहा है।
लैग कर रहा है, एक सेकेंड, नेट तो ठीक है, अभी ठीक आ रहा है, इंटरनेट तो ठीक है।
यस मैम।
बताइए व्हाट हाउ इन टर्म्स ऑफ फोर्स हम डायन्स में ही लेते हैं ना, और तो कैसे आएगा, व्हाट विल बी द यूनिट ऑफ इट?
डाइन पर सेंटीमीटर स्क्वायर पर सेकंड।
सो इट इज गोइंग टू कम आउट टू बी, फोर्स आप ले लो डायन में, और ये आपका एरिया सेंटीमीटर स्क्वायर, डी यू बाई डी एक्स कितना होगा, सेंटीमीटर बाय डी यू वेलोसिटी का सेंटीमीटर बाय सेकेंड, एंड दिस इज गोइंग टू बी सेंटीमीटर। सो फाइनली आपका आ जाएगा डायन सेकेंड पर सेंटीमीटर स्क्वायर क्लास। ठीक है, सो दिस इज गोइंग टू बी CGS, एंड SI में आपको पता है ये न्यूटन सेकेंड पर मीटर स्क्वायर। ठीक है, -2 हो जाएगा। ठीक है, so in SI units of the SI units are Newton second per meter square. ठीक है class, so the coefficient of -2, so coefficient of viscosity of liquid at any given temperature is the force which is required per unit area in terms of centimeter square। का बात करेंगे तो यहाँ पे तो ये न्यूटन हो गया, ये मीटर स्क्वायर हो गया, ये मीटर सेकेंड हो गया, और ये आपका मीटर हो गया। सो फोर्स दैट इज रिक्वायर्ड पर यूनिट area of layers to maintain a unit difference of velocity between the two parallel planes of the liquid 1 unit distance apart. Class, so the CGS unit of coefficient of viscosity is basically Poisson class. We talk in terms of Poisson also, Poisson class, but now this is unit की बात कर रही हूँ sir. This is a little higher unit which it's a larger unit. So normally in the experimental work we talk only in terms of the centipoise. कोई बताएगा what is centipoise और poise का relationship क्या होगा? Centipoise और millipoise और millipoise. तो लोग poise is a CGS unit, so it's a larger unit. So but when you do experiments in the lab, we realize that we have to take into account the smaller unit, that is centipoise or millipoise. So कैसे होगा ये बताएगा कोई? What is the relationship between poise and millipoise? Poise का poise से centi का relationship बताना सर।
10 to the power हो जाएगा।
हाँ, 10 the power -2 poise when we talk about the centipoise। ठीक है, और मिली में आपका हो जाएगा 10 the power -3 poise। आवाज आ रही है ना क्लास? आई थिंक मेरा नेटवर्क तो ठीक है, आप लोग अपना चेक करिए। ठीक है, सो नाउ द मेजरमेंट ऑफ विस्कोसिटी हम कैसे करते हैं इन द लैब क्लास। सो मेजरमेंट ऑफ विस्कोसिटी, कोएफिशिएंट ऑफ विस्कोसिटी भी कह सकते हैं, और खाली विस्कोसिटी भी कह सकते हैं खाली। ठीक है क्लास, कोएफिशिएंट भी बोल सकते हैं, टेम्परेचर ऑब्वियसली सेम रहना चाहिए, और खाली विस्कोसिटी भी बोल सकते हैं उसको क्लास। ठीक है, सो द कोएफिशिएंट ऑफ विस्कोसिटी ऑफ लिक्विड्स, दिस इज बेसिकली measured with the help of the Poisson-Willis equation class। इसको नोट कर लेंगे, that is why the word poise or the units of poise are being used। Poisson-Willis equation, sorry class, एक second। Poisson-Willis equation for the specifically for the laminar flow, for the laminar flow in a capillary। ठीक है क्लास. सो इन अ कैपिलरी ट्यूब. सो व्हाट इज दिस पॉइसनवेल इक्वेशन? ये इंपॉर्टेंट है क्लास, एग्जाम में इस पे क्वेश्चंस भी आए हैं और पॉइसनवेल इक्वेशन के बारे में पूछा भी गया है. ठीक है. सो इट इज बेसिकली योर V वॉल्यूम इज इक्वल टू 5/8 into PT R4 by beta L. Obviously at that temperature. Constant temperature के लिए. बस यहाँ तक clear है? ठीक है. So here in this Poiseuille's equation, which is V is the volume, which is equal to pi/8 into PT R4 eta L class. Eta is a coefficient of viscosity, L is the length of the tube, R is the radius of the capillary class. Radius of the length of the capillary, R is the radius of the capillary, and T is the time of the flow of the liquid which flows out from the capillary class. So I just tell you. So V is basically your volume of liquid. Class 11th में किया था आपने Poiseuille's equation.
हम फिजिक्स में होता.
V is the volume of liquid flowing out of the capillary in time t class. ठीक है. Volume of the liquid flowing out of the capillary in time t. अभी देखेंगे कैसे, इसके लिए कौन सा इंस्ट्रूमेंट यूज करते हैं. T is basically your, ऊपर लिख रही हूँ क्लास, T is basically your time in which volume V ठीक है. P की बात करेंगे. P will be your constant vertical pressure head for maintaining uniform volume flow rate, for maintaining uniform flow rate. Uniform flow rate is basically your basically uniform flow rate is your V by T. Excuse me. V by T. ठीक है क्लास, यहाँ तक क्लियर है. Now R is your radius of capillary tube. Radius of capillary tube. L is the length of the capillary. Eta is the coefficient of viscosity of the liquid. Now for any given capillary class, ठीक है क्लास, ये वाली इक्वेशन क्लियर है सबको. इक्वेशन नंबर 2, V is equal to pi/8 into PT/R4 eta L. सब कुछ आपका कैपिलरी का ही है. Everything is talking about the capillary. Now for any given capillary, कोई भी कैपिलरी अगर आपके पास होती है तो पाई हो गया, 8 हो गया आपका, R हो गया और L हो गया क्लास. ठीक है. These are all constant. Now if we assign the fixed value to the volume also, अगर हम वॉल्यूम को भी फिक्स कर देते हैं कि इस कैपिलरी से 10 ml ही जाएगा, 20 ml ही जाएगा, we fix the volume, तो आपकी जो इक्वेशन है that will get reduced to a new equation that will be your so when you fixed everything you will get this equation as eta is equal to KPT. क्लास ये इक्वेशन क्लियर हो गई. इक्वेशन नंबर 3, क्योंकि रिड्यूस इक्वेशन भी एग्जाम में पूछी गई है. हाँ या ना, रिचा, उज्जवल, तो 2 ही के नाम याद हुए हैं मुझे ना. नेता वो भी है, अंतिमा है. अंतिमा, आर यू देयर?
यस मैम, क्लियर है.
Clear, ma'am.
I can't go to that attendance wala sheet if I'm on the board. So this is the equation 3 which you get, and this K will all include all the constant terms. It will include all the constant terms. So it can be a modified equation from the Poisson-Willis equation, or it can be a reduced equation also. All the constant terms will include that class. Okay. Now this equation 3 basically class जो हम लोग करते हैं lab में is basically used for the comparison between the coefficient of viscosities of two liquids when the same capillary tube is used and the volumes made to flow through it are also same class. ठीक है. So now what happens is the capillary class. ठीक है. तो ये देख लेंगे this P has been related to the density class. So what happens basically the capillary जब बात करते हैं, the pressure head, this is basically P is your pressure head, because of which the liquid flows through the capillary tube is numerically equal to the weight of the liquid class. Okay, so how do we measure this? Now we'll just look at that. So I'm just erasing this. So the instrument apparatus which we use is equation 3 से याद रखेंगे. Apparatus which is used is your Ostwald viscometer. Ostwald's viscometer. इसके ऊपर आपका एक्सपेरिमेंट है. आई थिंक अगली नेक्स्ट टाइम में इनऑर्गेनिक ही चलेगा, फिर देन फिजिकल. वी मूव टू द विस्कोसिटी एक्सपेरिमेंट्स. 3 है शायद. सो नाउ दिस इज द क्लास में फिगर ड्रॉ करें. पहले लेट मी ड्रॉ, देन यू कैन ड्रॉ इट क्लास. ठीक है. ऑब्वियसली क्लैंप करना बहुत जरूरी है व्हेन वी आर डूइंग इट एक्सपेरिमेंटली. दिखा भी दूंगी अभी इसको ना, YouTube की तरह थोड़ा सा YouTube है. So this is a bigger size bulb. This is a larger bulb. Largest or the bigger bulb. And this is the smaller one. So here is the capillary. Fine capillary class. Okay. So these are marking obviously class. Okay. We all know that there is going to be marking up and there is a marking down also. Just to fix the volume. Markings are done just to fix the volume. And this is the smaller bulb class. Because bigger is the smaller bulb. Yeah, so this viscometer is basically you can clamp it class. ठीक है, इसको clamp करना ही पड़ेगा हमें. ठीक है, it's clamp from this side. No, this side. इधर से इसको clamp. ठीक है, this side. So you need to clamp this also. ठीक है, तो clamping कर लेंगे अभी. So the viscometer more commonly used for comparing the viscosities of the liquids is the Ostwald viscometer class. Okay, so this is the apparatus. Now this is a smaller bulb where here we have the capillary where the laminar flow will occur, and this is the larger bulb where you fill the volume of water. Here you will fill the water if you require water or you want to take any other liquid class. So here you fill it and then you suck it from this side class. So see, यहाँ पे suck होगा. Sucking is done, and then you under the constant vertical pressure head, you make the liquid flow from this capillary, and the volume is fixed. So if you choose any point M, you can choose any point N. So between the 2 points M and N, you choose so that the liquid flows. Class. First case, what do? We make the water flow from the point M to N in this capillary, and then you take the chosen liquid class. And then you can use the equation number 3 to compare it class. So what happens is the pressure head because of which the liquid flows through the capillary tube is numerically equal to the weight of the liquid, or we can say density से relate कर देंगे classes को, weight कह सकते हैं, numerically to weight of the liquid in this smaller bulk class. ठीक है. Now through this pressure, though this pressure head changes during the flow of the liquid, but we are only talking about that instant, that particular instant. It may be taken proportional to the weight, or it can be taken proportional to the density of the liquid. So when you talk about the equation number 3, that was the equation. You have to mention this, and you have to draw this, plot this diagram also. So when you talk about equation number 3, which is coefficient of viscosity, which is Kpt. K includes all the constant terms. Now this can be written as eta is equal to K, density of the liquid, and the time of flow of the liquid. So this is going to be equation number 4. Class यहाँ तक clear है?
Yes, ma'am.
Okay. So if you have have two liquids, so you can use the equation as eta 1 by eta 2, which is equal to K P1 T1 upon K P2 T2, which is equal to P1 T1 upon P2 T2, or it is equal to eta 1 by eta 2, it is equal to D. Say I am just putting D or rho is same, so density. So it is equal to D1 T1 upon D2 T2, or it can also be written as rho 1 T1 upon rho 2 T2. So class, what you do basically do is, make myself repeat कर रही हूँ. So you will take some liquid in this viscometer, and then in this from the larger bulb, you do it with the help of the volume. As normally we keep it fixed, so you do it with the help of the pipette, and then you suck from this side, and let the you calculate the time of flow of this liquid from any point above the bulb and any point below the bulb, keeping that, because that is basically to keep the volume fixed class. Okay, and then you note down the time of flow of the liquid. Density you can measure. Density आपको पता कैसे measure करनी है, using your weighing bottle. So you can measure the time of flow of the liquid, if it is water or it is unknown liquid class, and then you can use this equation to find out the relationship between eta 1 and eta 2. Class यहाँ तक clear है? ठीक है, क्लास क्लियर है?
Yes, ma'am.
Yes, ma'am.
Class, I think Oswald viscometer की अगर आपको details चाहिए तो you can look into the Kale Kapoor's book also. And क्योंकि apparatus का कभी कभी discussion पूछ लेते हैं, so they basically मैं एक बार फिर से बता देती हूँ, ठीक है? You can just the apparatus used is known as your Oswald viscometer, which is shown in this figure. It consists of two bulbs. These are the two bulbs. So two bulbs, you can take them as A or B, whatever you want to say, A and B, which are connected through a fine capillary. The bulb A is of the bigger size, whereas the bulb B is of the smaller size. Then what do we do? A known volume of the liquid is taken in bulb A, and the liquid is sucked from the side where we have the bulb B, and the time of flow is taken in seconds for the liquid to flow from mark M to mark N, and it is noted down, and by using the Poiseuille's equation you can find out the relationship of between eta 1 and eta 2. ठीक है क्लास, आई थिंक ये तो हो जाएगा, इसमें कोई दिक्कत की बात नहीं है. तो अगर प्रैक्टिकल में भी डिस्कस करेंगे तो देन यू कैन talk about what is basically the Oswald viscometer. क्या तक क्लियर है क्लास? आगे बढ़े या ब्रेक लेना है?
Yes, ma'am.
मैं अटेंडेंस तो डाउनलोड नहीं कर रही हूँ भाई। अगर ऐसा है कि कुछ बच्चे मतलब कि हो सकता है मतलब कि ना, इन केस यू वांट टू लीव आफ्टर फर्स्ट क्लास, तो जस्ट लेट मी नो, तो मैं आपकी एक क्लास की अटेंडेंस लगा दूंगी इन केस देयर आर स्टूडेंट्स हु वांट टू, देयर इज अ पॉसिबिलिटी। मेरे को पिछली बार ध्यान नहीं था। ठीक है, तो अभी कंटिन्यू करें या
ब्रेक दे दो मैम।
दे देती हूँ? ठीक है, ब्रेक ले लो, मैं आई आल्सो गेट कॉफी। ठीक है, आप ब्रेक लेके आ जाओ एंड देन वी स्टार्ट विद द इफेक्ट ऑफ टेम्परेचर। कंप्लीट कर देंगे लेकिन आज कोशिश करके ना, एंड डिफरेंट टाइप्स ऑफ विस्कोसिटीज क्लास। ठीक है, ठीक, ब्रेक ले लीजिए आप। 11 बजे मिलते हैं, 11:05 पे मिलते हैं। इसी क्लास को कंटिन्यू कर रहे हो, ठीक है? 10 Ds तो 30 है। ओके, Students, do you have Patania, Puri and Sharma with you people?
Yes, ma'am.
Yes, ma'am.
Is it available online?
Yes, ma'am.
If you can send it on the group or maybe on the email.
Okay, ma'am.
अभी भेज दीजिएगा, मैं तो बस बता रही हूँ. Then in that book you please all go through page 449 to page 449 to page 457. फोर 449 to 457 नोट कर लीजिएगा, मैं लिख देती हूँ. वैसे साथ साथ करते रहिएगा क्लास, ठीक है? बच्चे तो हैं जो जरूर कर रहे होंगे. सो पेज 4492 अच्छी बुक है, सिंपल है, समझने में आसान रहेगी. 457 ठीक है क्लास. सो और बताती हूँ मैं भी. देन क्लास वहां पे ना सॉल्व क्वेश्चंस तो दिए हुए हैं, अनसॉल्व क्वेश्चंस जो दिए हुए हैं पेज नंबर पेज 462 न्यूमेरिकल प्रॉब्लम्स जो दी है, प्रॉब्लम्स पेज 462. ठीक है, आप ये भी करेंगे. उसमें जो क्वेश्चंस आपके रिलेटेड होंगे सरफेस टेंशन से और विस्कोसिटी से क्लास. ठीक है, गामा नीटा. सो क्वेश्चंस आप करेंगे. एक दो क्वेश्चन के आंसर में कहीं पे थोड़ा सा इशू है, बट अदरवाइज सारे क्वेश्चंस करेक्ट हैं क्लास. ठीक है, सो ये डाउट सबने करना ही है. ठीक है, सो मूविंग फर्दर. सो क्लास विस्कोमीटर समझ में आ गया सबको. So we have obviously equation number what was that equation? The equation number was eta 1 by eta 2, which is equal to the density d1 t1 upon d2 t2. इसके ऊपर numericals आएंगे. You will get numericals for sure. Because surface tension और viscosity से एक ही क्वेश्चन जरूर आता है हर साल ना. कोशिश ये रहती है कि सारे टॉपिक्स कवर हो जाए, सब टॉपिक्स के क्वेश्चन आपके आ जाए. सो दिस कैन बी used now class. When we talk about, we have something which is called as the different types of viscosities also. A relation which is to this relative ratio viscosity only class. Different types of viscosities. So here class number 1 is your relative viscosity. ठीक है, जो आपने भी पढ़ा ही है, that is given as eta relative REL, which is again going to be your eta of the given liquid upon eta of the water. Water को normally भी use करते हैं. Water ही क्यों use करते हैं class? Which is equal to time of the flow of the liquid upon time of the flow of the water into density of the liquid upon density of the water, dA plus A. वाटर ही क्यों यूज करते हैं? सो ईटा एल आपका आ गया, ईटा रिलेटिव. ठीक है, आपका आ गया. डेंसिटी का 1 मानते हैं इन केसेस व्हेन योर the liquid is also very dilute or it has little you have made an unknown liquid with water only. So you can, at times you can take density of liquid to density of water and approximately equal to 1. So then your eta relative will become as time of flow of the liquid upon time of flow of the water class. So simplify with this equation. Densities are comparable, or for the liquids which have the densities closer to the water class. Okay. So this is the relationship. Now where we know that eta relative is the ratio of the time of flow of the liquid to time of flow of the water class. So the second viscosity, this is the relative viscosity. This we have the specific viscosity. Specific viscosity, which is basically defined as eta specific, which is equal to eta relative minus 1. Eta relative minus 1 class. Okay. So this relationship can also be used to find out the eta specific. Then third is your reduced viscosity. Reduced viscosity. Then how it is used, we'll just look at the application also. Reduced viscosity, it is eta reduced, which is equal to eta specific by concentration class. So division of eta specific by concentration will give you the eta reduced or a reduced viscosity class. So 3 types of viscosity. कभी exam में पूछ लिया what are the different types of viscosity and what is the relationship of each of this viscosity to your eta relative class. ठीक है, तो इस टाइप के क्वेश्चन पूछे गए हैं, तो हमें पता होना चाहिए क्लास. ठीक है, प्लस अब मुझे फटाफट से बता दो what is the relationship between the temperature and viscosity, effect of temperature on viscosity.
Viscosity
डिक्रीज हो जाता है ना टेम्परेचर इंक्रीजेस के साथ.
हाँ ठीक है, effect of temperature on viscosity. ठीक है, so the relationship of coefficient of viscosity and the temperature is basically given by eta is equal to EA by RT. So as you increase the temperature, so it's a linear relationship. ln लेते हैं दोनों, ln eta is going to give you ln A plus EA by RT. ठीक है, so class obviously we know that E is the activation energy and A is the constant class. So we're not going to detail of that. Temperature और eta specific का relationship का देखते हैं. So it is basically as you increase the temperature, the viscosity decreases with the increasing temperature. So and EA we all know that is the energy to be given to the molecule of liquid to allow its molecules to overcome the forces of the resistance of the liquid class. Okay. So when you use this equation, so your this eta ln eta, it will decrease, and eta also will start to decrease as you increase the temperature. Temperature increases class. ठीक है. So अगर आपसे एग्जाम में पूछना, आप इस रिलेशनशिप बता के फिर बता दीजिएगा कि it decreases as you increase the temperature class. ठीक है क्लास, आई थिंक यहाँ तक क्लियर है सबको, कोई दिक्कत नहीं.
क्लियर है मैम.
मैम ये तो Arrhenius equation होते हैं ना?
हाँ, ये Arrhenius equation होती है, but this is applicable for the viscosity also. Arrhenius equation में माइनस आएगा. ठीक है. कंट्रोल ये मैं एक एक्स्ट्रा बता रही हूँ क्लास. ठीक है, this is a part of it, but फिर भी बता रही हूँ. ठीक है, you know what these three relationship which I've talked about, the viscosity, that eta relative is there, then you have the eta relative के बाद आपके पास कौन सी viscosity मिल रही, specific आपको बताया मैंने, और कौन सा बताया, reduce बताया क्लास. ठीक है. Now these just by using the eta relative, you can experimentally calculate the molar mass of the polymer by the measurements of viscosity class. Okay, ये भी experiment आपके syllabus में नहीं, but honors में था. But there is a formula to calculate molecular mass of a polymer by measurement of viscosity. So here the intrinsic viscosity. So this is basically your intrinsic viscosity. viscosity, it is equal to K M alpha. I बता रही हूँ क्या it is. It is known as your Markov equation. Markov equation. Now you can just take a log of this, log beta, which is equal to log K plus alpha log M. Alpha is a constant class. This is very specific to the polymer class. अभी देखते हैं. So log M, which can be written as log eta is minus log K upon alpha, and we say that after solving it you get the answer as X class. ठीक है? X we say. ठीक है? So your M will come out to be NT log of X, which is equal to Y. So M is equal to Y class. Now your M is basically your molar mass of the polymer. Molar mass of the polymer, which will be which is equal to Y, which is in units of gram per mole class. Gram per mole, and K and alpha are constant. K and alpha are constant class. Because now these are basically constant for that specific polymer you're talking about. So they're very specific to polymer. Specific to polymer. ठीक है, so इनकी वैल्यू already दी हुई होती है, आपको डेटा अवेलेबल रहता है. So now you by just using the viscosity measurements, you can find out the molar mass of the polymer. Now how this intrinsic viscosity is related to the eta relative, or you can where we had started calculating. Classes को note कर लीजिएगा. वैसे I don't think so तुम्हारे syllabus का है part, but कभी-कभी mark होंगे equation पूछ ली by chance ना, तो पता होना चाहिए कि what is specifically it is used to measure the molecular mass of the polymer. और ये lab में possible है. This application of the viscosity is very much possible. You can determine the molar mass of the polymer in the lab actually. किसी के पास अगर if you have that book called practical book by B.D. Khosla, it is specifically for the physical chemistry experiment, and it is very good class. ठीक है? So if you can find it out online, if it is available, then you go to that chapter of determination of viscosity and surface tension, so you realize how this experiment has been done class. So this was your class. को erase कर दूं अगर note कर लिया तो.
Yes, ma'am.
So,
Yes,
so your this was your intrinsic viscosity. Intrinsic viscosity, which is basically equal to in the limit of when concentration goes towards zero, it of the eta reduced. So जो आपकी eta reduced है, eta reduced का relation मैं आपको बता चुकी हूँ. So eta reduced when the concentration goes to zero. So on that axis wherever you plot the eta reduced, on that axis when you take the concentration to zero, it will give you the value of the intrinsic viscosity. Now the intrinsic viscosity can be put in that formula which we had done earlier अभी किया है, and then you can find out the molar mass of the polymer can be calculated class. ठीक है? So this can be found out by plotting a graph between C and eta reduced class. Okay, and then extrapolating the to the y-axis. This is basically plotted in the y-axis class. Okay, so this is your eta reduced, which you can find out. It is eta specific by C. हम सबको पता है. And this is your concentration gram per 100 ml liquid. So this is the type of graph you are going to get class. Okay, sorry, मेरे को points पहले बनाने चाहिए थे. So you just have to reduce it to the concentration zero. So this point, this is going to give you the eta specific class. So इसकी और details नहीं बता रही हूँ, इतना आपको बता दिया मैंने, ठीक है? So you can use this equation to find out the molar mass. Class clear है यहाँ तक? Yes or no?
Yes, ma'am.
क्लास मुझे फटाफट से जो मैं पूछूंगी तुम लोग बताते रहना, जो थोड़ा सा रह गया वैसे भी विस्कोसिटी का. This is a question. How will you what do you say about the viscosity of glycerol or honey? And if it is high, what is the reason behind it? इसको erase कर रही हूँ, आप note कर लिया class?
Yes, ma'am.
Yes, ma'am.
ठीक है. Class जो viscosities हैं, I'm just giving you one value, coefficient viscosity of some liquids at 20 degrees Celsius. ठीक है. Now for water, I think it's in the units of poise and Newton per meter. Okay, so for water we have, it is around 10.02 in the units of poise में कर देती हूँ क्लास, poise into 10 raised by 3 जाएगा आपका. ठीक है. So now for water it is 10.0, but for glycerol it is around 8550. एक तो आपने मुझे बताना what is the reason behind it, and you have a little higher value for ethylene glycol also. Ethylene glycol also, which is around 199, but obviously it is too high. So फटाफट से बता देगा what is the reason for that? कोई भी बता देगा, तो बहुत easy है, 11th 12th से पढ़ते आ रहे हैं. Class, it is basically a reason. You can want to write, you can write down also. If you look at its glycerol का formula क्या होगा क्लास, बताइए. अंतिमा, ग्लिसरॉल का फॉर्मूला सबको पता है. It is CH2OH, CHOH and CH2OH. यही है ना. ठीक है. So what happens? The coefficient of viscosities of associated liquids, they are basically associated liquids known as associated. Honey का viscosity इतना high क्यों है? Associated liquids. Liquids coefficient of viscosity of associated liquids are larger than those of the non-associated liquids class. ठीक है. For example, if you talk about coefficient of viscosity of C2H5OH is given a coefficient of viscosity of C2H5O, C2H5 class. अब आप इसको देख के बता सकते हो ऐसा क्यों है.
Hydrogen bonding.
Hydrogen bonding, but it is largely due to the, this is the case, क्योंकि एग्जाम में पूछा जाएगा तुम लोगों से ना. हाइड्रोजन बॉन्डिंग तो हम सबसे पहले सोचते हैं. हाइड्रोजन बॉन्डिंग बिटवीन द मॉलिक्यूल्स ऑफ द लिक्विड. So what will happen between a molecule and liquid? They will get associated, so they're known as associated liquids class. ठीक है. So glycerol हो गया आपका, ethylene glycol हो गया, have comparatively larger values of coefficient of viscosity since they have more than one hydroxyl group. ये इसमें single hydroxyl group, but it will get associated like this, C2H5OH. Now इसको हम लिख सकते हैं C2H5OH. ठीक है class. And then we have the other molecule C2H5OH. They all get associated class. So this will get to associate with other molecule of C2H5OH class. Okay? So they'll get to associate, and as a result, you realize that they keep on bonding together. Now it is more in case of these glycerol and ethylene glycol because their coefficient of viscosities are higher because they have more than one hydroxyl group. Class लिख लीजिएगा इसको कि because glycerol has got more than one hydroxyl group, or ethylene glycol has got more than one hydroxyl group. Okay? Now they'll get associated. So because of these hydroxyl, a network of hydrogen bonds is formed between the molecules, which extends throughout the liquid, and they will offer greater resistance, and then the values of eta increases. ठीक है class, clear है? एक molecule will get associated with the other molecule of the same molecule, उसके साथ associated रहेगा. I think that's clear है, यहाँ तक तो हो जाएगा.
Yes, ma'am.
ठीक है, so आप you can draw the structure class, ठीक है, जब यहाँ पे draw करोगे तो obviously it will come out like this. So बस ये है, यहाँ पे O है आपके पास, then you have the OH, इसकी बात कर रही हूँ, CH2OH, CHOH and CH2OH class, ठीक है, so CH2OH, CHOH and CH2OH. Now you take the other molecule. It's उसका OH. Now they'll start to sketch को ऐसे ले लेते हैं. They'll start to interact. Same way here, and then again here also. And strong network will get formed. ठीक क्लास, तो इसके ऊपर क्वेश्चंस आएंगे, तो यहाँ पे इंपॉर्टेंट लिख लीजिएगा. So questions on the glycerol, ethylene glycol, and as compared to what it will come to. Then comes your class. किसी को fluidity पता है? What do you mean by the word fluidity?
I'm reciprocal of viscosity.
So उसके ऊपर short note पूछा गया है. So fluidity is basically the flow of liquid can also be expressed in terms of fluidity. It is basically the reciprocal of viscosity. So it is 1 by eta class. So viscosity का reciprocal है. So the fluidity of a liquid depends on the various factors. So one factors आप बता सकते हैं. बहुत ज़्यादा डिटेल में नहीं पूछा है, थोड़ा सा ही पूछा है. So I'll just let you know. Heavier and larger molecules, they flow heavier and larger molecules, they flow less easily than the lighter and the smaller molecules. Flow less easily than the lighter and smaller molecules. Than the lighter and smaller molecules. Then you have spherical molecules. Spherical molecules offer a less resistance to flow than the plate-like molecules. And impurities. Important is impurities increase the viscosity of liquid. So the impurities है तो fluidity को कम कर देंगे. Impurities increase the viscosity of the liquids class. So this is little important class. Class 1 में नीरा मैम का फोन आ रहा है. क्लास में कुछ पूछा था ज्यादा आपसे ना, या हो गया है? सो ये आपका क्लास Class, can you hear me?
Yes, ma'am.
Yes, ma'am.
So impurities they basically increase the viscosity of the liquid class. तो उसका reverse आपका fluidity हो जाएगा class. ठीक है? So this is all done. क्लास में मैं आपको एक न्यूमेरिकल दे रही हूँ, आप न्यूमेरिकल सॉल्व कीजिए. इन द मीन टाइम जस्ट चेक आउट की कुछ रहा तो नहीं है. That will be basically onto the formula. हाँ, this right. At 20 degree Celsius. अभी करना है क्लास, ठीक है? आप करके चैट बॉक्स में डाल दीजिए. 20 degree Celsius, pure water with an absolute viscosity of 1.002 into 10 the raised power minus 3 Newton per meter square second requires 102.2 seconds to flow through the capillary of an Oswald viscometer. At 20 degrees Celsius, toluene, this is for water, toluene requires 68.9 seconds. If densities of water and density of toluene are 0.998 and 0.866 gram per centimeter cube. Again, this is gram per centimeter cube respectively. Calculate the viscosity of toluene. क्लास में रिपीट कर रही हूँ, बुक से नहीं देखना है, खुद से करना है. जैसे पिछली बार कहा था वैसे ही करना. डेटा लिखिए क्या रिक्वायर्ड है और कैलकुलेशंस कीजिए. At 20 degree Celsius, pure water with an absolute viscosity of 1.002 into 10 power minus 3 Newton per meter square second requires 102.2 seconds to flow through the capillary of an Oswald viscometer. At 20 degrees Celsius, toluene requires 68.9 seconds. The densities of water and toluene be 0.998 and 0.866 gram per centimeter cube respectively. Calculate the viscosity of toluene. आप ही कीजिए क्लास, ठीक है? टेक योर 5 minutes और ठीक से करना है क्योंकि कुछ न्यूमेरिकल्स के आंसर में कहीं कहीं पे गड़बड़ भी है. ठीक है, कीजिए.